This video is going to take a look at setting up and solving a set of equations to handle perimeter problems. And in this particular case, the perimeter of a rectangular playground is 960 feet. The length, it says, is twice as long as the width. What are the dimensions of the playground? Now, we could fool around with some arithmetic and eventually solve these problems, although the numbers are kept easy enough. The whole goal of this is to learn how to develop equations to solve problems algebraically, and these problems certainly can get more difficult than the examples that we're going to use in our class here. And so the idea isn't just to get right answers, it is to learn how to think algebraically about a word problem. And so it turns out that there are really two things we don't know if you take a look at the rectangle. We don't know the width and we don't know the length. So when that happens, one equation's not going to do it for us because we'll have two unknowns. I mean, we know how to solve equations where x is the only variable, for example, but we have two different variables that are not known in this problem. So it won't be any surprise to me that I end up with two equations in order to solve this. The first equation is just a standard geometry formula of how you find perimeter. Perimeter of a rectangle is two lengths plus two widths. That would be the distance around, and that is what perimeter is. So I'm going to start with two widths plus two lengths is a known value in this problem of 960 feet. But like I said, you can't really solve for W or L. In this case, I mean, you could, but it won't be a numerical value that represents the width or the length. It'll be in terms of the other letter. So is there enough information to get a second equation? And it turns out, it does say here, that the length is twice as long as the width. So what that is saying is, algebraically, if you looked at the width and you compared it to the length, it's saying that this length is twice as long as the width. In other words, it would take 2w to equal the length, because the length is twice the width. And there is my second equation. I could say that L is equal to 2w. And what that is going to allow me to do is what we call algebraic substitution. In this original problem, I could replace L with its equivalent of 2w, and we could substitute. Now we still have two lengths, so that means we still have two sets of 2w, which represents the length, equals 960, and that is a solvable equation. We know how to solve those. We would distribute, and we're going to collect like terms and simplify this right-hand side. This would become 4w. I now have a total of 6w equals 960, and when I divide by 6, and we'll do that on our calculator here, 960 divided by 6 turns out to be 160 feet is the width. So the width is equal to 160 feet, and since we know the length is twice as much, we could say here that the length is 320 feet. Now we have found the right dimensions that would give me a 960 foot perimeter. And by the way, you know, back to this, why did we end up with 6w? Think about the fact that if this length is equal to 2w, and if this length is equal to 2w, I really had a total of w plus 2w plus w plus 2w. Now the math worked itself out for us to find 6w, but you could see it here as well on the picture. Okay, I'm going to do a second problem, and the main reason is I want to compare language here. This problem is very similar intentionally. It says the perimeter of a rectangular playground is 960 feet. Same first sentence as the problem we just did. So same equation as the problem we just did. 2w plus 2l is equal to 960. But what is different is the relationship between the length and the width. Here it says the length is 2 feet more than the width. It isn't twice as much. So the way that works is if I had the width here and I had the length here, this length is found by adding 2 more feet right here. And it is not twice as much, it's 2 more than. It's an addition problem. And so now my equation relating length to width is L is equal to W plus 2. So this time, when I do the substitution, I'm going to need what we have been calling distribution, because I'm going to get 2W plus 2 times what the length is equal to, which is W plus 2. And if I looked at a sketch of the perimeter of this particular problem, it's a little different than the last one in that this time I have W here and W here, but this length is W plus 2, and this length is W plus 2. So let's see if this math turns out to give me the same perimeter in terms of W that I think I would get if I started adding things up around this rectangle. This would be distribution, because that's what we always do when we have a number outside of parentheses. So this would be 2W plus 4. And then I would get 4W plus 4 is equal to 960. We'll take a look here. Let's just compare it. Here I would have W, 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 and W would be 4W, and 2 would be 4. Now I just solve the equation, subtract 4. That would be 956. And I have 4W is equal to 956. I just need a little room, so I'll bring it up over here. 4W is equal to 956. I'll divide both sides by 4, and I will have the width that would meet the criteria of this problem. Let me just go ahead and do that right here. 956 divided by 4. It gives me a 239-foot width. And because of the relationship I already had about length, 2 more than that would give me 239 plus 2, or a 241-foot length.